Good morning, children. Here I am continuing with the chapter, the basic constituents of matter. Now we have come to the last part of the chapter. Today we are going to study how we are going to represent atoms and molecules. Okay, so just for an example, helium, neon, argon, carbon, etc. Now, see, when we are writing like this, there is just helium, neon, argon, carbon, etc. By writing this, we are representing one atom of the element. We are representing one atom of the element. Okay. Now, since we are representing one atom of the element, that is these elements, they can exist independently. They can exist like this as a single atom. Okay, since this element contains only one atom, we call them as monoatomic molecule. Okay, monoatomic molecule. Okay, monoatomic molecule. Mono means one atom. Okay, then now what about 2 helium, 2 argon? Okay, so when we are writing this 2 helium and 2 argon, if you are writing a number on the left side of this element, you can see that we are representing 2 atoms of helium. Okay, 2 atoms of helium or 2 atoms of argon. Okay, here we are representing it as 2 atoms of helium or 2 atoms of argon. Now, see, O2, Cl2. Okay, here we are H2. Okay, here these O2, Cl2 and H2, we represent them as O2, Cl, not a single atom, but they are 2 atoms are combined together here, isn't it? We are combining them. And here, since there are 2 atoms, we call them as diatomic molecule. Diatomic molecule. Okay, diatomic molecule. Di means 2. So now here you can see as 2 atoms. Here also 2 atoms. Now there are some elements which we cannot express them as either a monoatomic molecule or as a diatomic molecule, like phosphorus, sulfur, etc. One more, O3, ozone. Okay, so here this phosphorus, sulfur and ozone, see how many atoms are there in a single molecule? 4 atoms. In a single phosphorus molecule, you can see 4 atoms. Then in a single sulfur molecule, you can see 8 atoms of sulfur. In a single ozone molecule, you can find 3 oxygen atoms or 3 ozone atoms or 3 oxygen atoms. Okay. So here, these are known as, there is more than 2 atoms. When a molecule is containing more than 2 atoms, we call them as polyatomic molecule. Poly means many. Okay. So we call them as polyatomic molecule. Okay, so monoatomic, diatomic and polyatomic molecule. Okay, so I hope that you have understood how we are representing this monoatomic and diatomic. Now in this table I have written the names, symbols of some substances, number of molecules, total number of atoms. So if you have understood the concept that atom and molecule, you can easily fill up the number of molecules and the total number of atoms. Okay, we'll do it. Now see, This is O2. What is the number of molecule here? Even if it is not represented here, you can see that it is only one molecule. And in this one molecule of oxygen, how many number of atoms are there? 2. 2. Here, 2N2. What does this 2 represent? This 2 can represent either the number of atoms or the number of molecules. So here you can see that there are 2 molecules of nitrogen. So 2. And what about the total number of atoms? Here if you are writing like this, you can understand that in one molecule of nitrogen 2 atoms are there, isn't it? Now see 2 molecules. So how many number of nitrogen atom? 2 into 2, that is 4. Here how many chlorine molecules? 6, isn't it? 6 chlorine molecules. How many number of atom? 6 into 2, 12. Here how many molecules of helium? 2. Here how many molecules of neon? 5. Here how many molecules of ozone? 1, isn't it? Even if it's not written there, you have to understand that it is like one molecule. Okay. Now what about the number of atoms? 5, isn't it? 5 number of atoms and 5 molecules. And what about here? It is 2. Okay. Now in this way you can understand that how we can represent the number of molecules and the total number of atoms here. So here it is one molecule of oxygen. In one molecule of oxygen, 2 atoms are there. Here 2 molecules of nitrogen are there, and total number of atom 2 into 2, that is 4. Here 6 chlorine molecules and total number of atom 6 into 2, that is 12. Here how many number of, this 2 is actually we are representing the number of molecules as well as the number of atoms. So here 2 molecules as well as 2 atoms. Here also 5 molecules of neon and the same way 5 neon atom. And what about here? Ozone. There is 1 molecule of ozone, and how many number of atoms? Now some compounds are given here. Now if I am asking you to write how many number of atoms are there in each compound, okay, what will you say? There are 2 hydrogen atom and 1 oxygen atom, isn't it? In one molecule of this compound, in one molecule of water, there is 2 hydrogen atom and 1 oxygen atom. Here in one molecule of carbon dioxide, 1 carbon atom and 2 oxygen atom. Then what about here? You know, this is sugar. Okay, so this is 12 carbon atom, then 22 hydrogen atom and 11 oxygen atom. Okay, so if some questions are asked like this, if the names of some compounds are given here and they will be asking you to write find out the number of atoms present in each molecule of the compound. See, you can see this is 1 water molecule, this is 1 carbon dioxide molecule. So if they are asking you to write the number of atoms in each molecule of the compound, you can write it as 2 hydrogen atom and 1 oxygen atom. 1 carbon atom, 2 oxygen atom, and 12 carbon atom, 22 hydrogen atom and 11 oxygen atom. Carbon dioxide is a compound which is formed with the help of 2 different elements, that is carbon and oxygen, isn't it? So we all represent the compounds or some elements using symbols that we have studied. Now from whatever source we are getting carbon dioxide. For example, see, carbon, when it is burning in oxygen, we are getting carbon dioxide. Okay, this is one method by which we are getting carbon dioxide. Another method, if I tell you, that is burning of or decomposition of calcium carbonate. Okay, calcium carbonate. Calcium carbonate is something that is present in marble, then in the eggshells and all. Okay, so this calcium carbonate, when it is when you are heating it, okay, it gets decomposed and it gets split up to form calcium oxide and carbon dioxide. So see, in these two equations, there is burning of carbon in oxygen as well as this decomposition of calcium carbonate from whatever source. These two are different reactions, isn't it? Two different sources from where we are getting carbon dioxide. So whatever be the source, the formula always remains the same, isn't it? Carbon dioxide, because this carbon and oxygen will be combining together in a definite ratio, that is 1:2, isn't it? This carbon and oxygen will be joined together in the ratio 1:2. Similar with water also, isn't it? The water is always combined together in the ratio 2:1. 2 hydrogen atom and 1. So here I have represented H2SO4. Does anyone know what is H2SO4? Yes, sulfuric acid, isn't it? Sulfuric acid, which is the king of chemicals. Okay. Now, here I have represented one molecule of sulfuric acid. Okay. I have represented one molecule of sulfuric acid. Now, I am asking you, how many number of hydrogen atoms are there? How many number of hydrogen atoms are there? 2. What about sulfur atoms? 2. Sorry, not 2. It's 1. Okay. Now, what about oxygen atom? It is 4. Isn't it? 4. Now, total number of atoms. What is the total number of atoms in one molecule of sulfuric acid? 2 plus 1, 3. 3 plus 4, 7. Okay. So, in one molecule of sulfuric acid, altogether 7 atoms are there. Okay. Then, in one molecule of sulfuric acid, 7 atoms are there. Okay. In one molecule of sulfuric acid, 7 atoms are there. Then what about 2 molecules of H2SO4? Yes, right. 2 into 7, that is 14 atoms. See how easy it is? So, in one molecule of sulfuric acid, we found out that there are 7 atoms. Then what about 2 molecules of sulfuric acid? Yes, 14 atoms. Now, another example. Then carbon dioxide. Carbon dioxide. How many number of atoms are there? 1 carbon atom. Then 2 oxygen atom. Isn't it? 2 oxygen atom. Altogether how many number of atoms? 3 atoms. Okay, in one molecule of carbon dioxide, 3 atoms are there. Okay, another example. 5H2O. 5H2O. 5 molecules of water. Okay, so first we will find in one molecule of water. If you are taking one molecule of water, how many hydrogen atom? How many oxygen atom? 2 hydrogen atom, 1 oxygen atom. Altogether 3 atoms. Okay, 3 atoms. So what about 5 molecules of water? 5 molecules of water. So in one molecule of water, if there are 3 atoms, total 3 atoms, what about 5 molecules of water? 5 into 3, that is 15 atoms. Okay. So this is the way how we are finding out the total number of atoms present in each molecules of the compound. Chemical equation. Okay, so when you turn around, you can find different types of chemical reactions taking place. If you go to your lab, in your school lab, you can find out different types of reactions we can perform, isn't it? So these chemical reactions can be represented using chemical equations. Okay, so chemical equation, actually we are using it to represent the reaction between either similar elements or dissimilar elements, and also we will be getting the result also, isn't it? For example, I am writing an equation here. Zn plus HCl gives ZnCl2 plus H2. Here Zn is zinc, okay, HCl is hydrochloric acid, okay, then ZnCl2 is zinc chloride. Okay, so this is a typical reaction, that is how the zinc is reacting with hydrochloric acid. I have represented it using symbols. Okay, I have represented it in the form of a chemical equation. Now, see here on the left side of the arrow, you have written zinc and hydrochloric acid. Okay, the elements which are present on the left side of the arrow are known as reactants. Reactants. Okay, the elements which are present on the left side of the arrow, they are known as reactants, and whatever we are writing on the right side of the arrow is known as products. Okay, so reactants are those substances which are participating in the chemical reaction. Okay, the reactants are those substances which are participating in the chemical reaction, and whatever things we are getting after the reaction is complete, they are called the products, and we will be representing them on the right side of the arrow. Okay, okay, now when you are writing the equation, okay, when you are writing the equation, we have to make sure that the number of reactants and the number of products should be equal. Okay, whatever number of atoms are present in the reactants, the same number of atoms should be there in the products also. How can we make that happen? Yes, by balancing them, isn't it? When you go to the shop, you know how they are balancing the pans, isn't it? By putting the weight here, and how they are putting the vegetables or fruits in the other pan, and how they are balancing them. Then only they will give us. In the same way, in chemistry also, we are having balancing the chemical equation. So I will show you how we are going to balance this equation. Okay, zinc plus HCl will give you ZnCl2 plus H2. Now I am going to find out whether the equation is balanced. Okay, so for that I will be writing zinc, hydrogen, chlorine. Whatever elements are represented here, I will be writing it here. Then reactants are and product. Okay, so this is before balancing. Okay, now I'll draw a table like this. Okay, I'll draw a table like this. Now, in the reactant side, okay, in the reactant side, you can find only one zinc atom. What about hydrogen? 1. What about chlorine? 1. Okay, so in reactant side, one zinc atom, one hydrogen atom, and one chlorine atom. What about in the product side? Product also, zinc is 1. Okay, good. What about hydrogen? 2. Oh. And what about chlorine? Oh my god. See, only zinc, both in reactants and products, the number of atoms is same. But in hydrogen, in the reactant side, the number of atoms was 1. But in the product side, the number of atoms is 2. Same thing with chlorine also. Now what I have to do? Now, since zinc is the same, I am not going to zinc. Then I am going to hydrogen. Okay. See, here in the product side, there is already 2 hydrogen atoms. But here you have only 1 hydrogen atom. So what you will do to balance? You will put 2 here. Isn't it? You will put 2 here. Okay, see, our hydrogen is balanced. Now what about chlorine? In the product side, there are 2 chlorine atoms. In earlier, before putting 2 here, there is only 1 chlorine atom. But now since I have put this 2 on the left hand side of the chemical formula, this 2 is applicable to hydrogen as well as to chlorine. Okay, do you understand? If I am putting a number on the left hand side of the chemical formula of any compound, that 2 is applicable to all the elements here. That is to hydrogen as well as to chlorine. So now how many number of chlorine atom? Yes, 2. Okay, 2. Now I am going to write the balanced equation once more. That is Zn plus 2HCl gives zinc chloride plus hydrogen. So now the number of atoms in the reactant side and the number of atoms in the product side are equal. Now I have balanced the equation. Now another example. C plus O2 gives CO2. Here you can see that the carbon atom, here there is 1 carbon atom, here also there is 1 carbon atom. What about oxygen? Here also 2 oxygen atom, here also 2 oxygen. So this equation is already balanced. Some cases are like that also. They will be giving us the equations and asking us to balance. Then when we are checking it, we will find that it is already balanced. There are cases like that also. Now, H2 plus Cl2 gives HCl, and they are asking you to balance it. So what you will write? Hydrogen and chlorine, reactants and products. Okay. Here in reactant side, 2 hydrogen atom, 2 chlorine atom. What about in product? Only 1 hydrogen atom and 1 chlorine atom. So what you will do? Since here there is 2 hydrogen atom and 2 chlorine atom, easily you can put 2 here. So earlier I told you this 2 is applicable to hydrogen as well as to chlorine. So now there are 2 hydrogen atom and 2 chlorine atom. So we can rub it here and write 2 and 2. Now what is the equation, balanced equation? H2 plus Cl2 will give you 2HCl. Okay. Then now another equation is N2 plus H2 gives NH3. Okay, N2 plus H2 gives NH3. Now here I am writing NH. Reactants, product. Okay, how many number of nitrogen atom here in the reactant side? 2. Number of hydrogen? 2. What about in product? Only 1 nitrogen atom and 3 hydrogen atom. Oh, now what I am going to do? How will I balance it? Okay, so here it is 2 nitrogen atom in the reactant side, only 1 nitrogen atom in the product side. So what will I do to balance? I will put 2 here, isn't it? Now nitrogen is balanced. 2 nitrogen, 2 nitrogen. Okay, it is balanced. Now, what about hydrogen? Hydrogen, now there are 2 hydrogen atoms in the reactant side. And what about this ammonia? This hydrogen atom? This 2 is applicable to nitrogen as well as to hydrogen. So, 2 nitrogen atom, okay, right? How many number of hydrogen atoms are there? 2 into 3, that is 6 hydrogen atoms are there now. 6 hydrogen atoms are there. Now what I have to do? Here only 2 hydrogen atoms. Now I am going to ask you something. In your multiplication table, what must be multiplied to 2 to get 6? Yes, already 2 hydrogen atoms are there. Now what should I do to make it 6? Multiply it with 3, isn't it? If you multiply it with 3, you will be getting 6 here. So what I will do? I will put 3 here. So 3 2s are 6. Okay. So now here 6 hydrogen atom and 6 hydrogen atom. Okay. So here 2 nitrogen atom. This 2 you should always keep in mind that this 2, when you are writing a number here on the left hand side of the chemical formula, that number is applicable to whatever elements here. That is to nitrogen as well as to hydrogen. Here in hydrogen, since already there were 3 hydrogen atoms, we can multiply that 3 into 2 to make it 6. So 6 hydrogen atom. And in order to make here this hydrogen atom balanced, what I have done? Earlier there were 2 hydrogen atoms. To make it into 6, I multiplied it with 3. So here 6 and here also 6. So everything balanced. So now I will write the equation. N2 plus 3H2 will give you 2NH3. Okay. So this is all about chemical equation. Now thus we have completed the chapter Basic Constituents of Matter. Thank you all of you.